Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host, as usual, is Tobias Macy, and today I'm interviewing Michael Foord, mockingly, about his career in Python. So, Michael, could you start by introducing yourself?
Hello, everyone. Yeah, I'm used to being mocked, particularly for my career in Python. I'm sorry, I have a very strange voice today. I'm on the tail end of a cold and sore throat, so I sound quite different from normal. But I'll introduce myself. My name's Michael Foord. I've been developing with Python since about 2002 and commercially since 2006. I'm probably best known back in the dim and distant past for my work with IronPython. I worked for a small firm in London, and we were the first to commercially use IronPython, so I ended up writing a book called IronPython in Action. And then whilst there, at the same company, I became passionate about testing and wrote a tool called Mock, which is now in the Python standard library as unittest.mock, and I became a Python core developer. I maintained unit tests for quite a long time. I did a whole bunch of features, and I've had a whole other bunch of other adventures with Python since as well.
And do you remember how you first came across Python?
So it was sheer serendipity, really. At the time, so this is back in sort of 2001, 2002, that kind of era. I was actually working in a builder's merchant selling bricks and timbers for a living. I was in heavy-side sales, but I'd started this play-by-email game where everyone emails their orders in every week, and a computer processes it all and sends you back the reports of what's happened, your adventures and battles and things you've discovered. So the really interesting bit is the sort of diplomacy that happens by email in between. And this is back in the sort of early-ish days of the internet. And a bunch of us, we had this alliance, and it was us against this other one big character. And some of us said, hey, wouldn't it be really interesting? These reports are generated by a computer. The orders are a very simple syntax for a computer to understand. We could write some software, some little bots that could automate all of this and maybe even fight each other. And we settled on, for some reason, we settled on Smalltalk as the language. And at the very last minute, someone said, hey, you should use Python for this. And we said, all right. And somebody else wrote the parser, a regular expression parser that understood the reports. And then on top of the data structure that spit out, I did an implementation of Dijkstra's algorithm for pathfinding. I sort of did maps and all sorts of interesting stuff with that. And Python and programming became my passion again. Having not done any for about a decade, done very bit before university, a bit of 68,000 assembler on the Amiga, BBC Basic on the 8-bit BBC microcomputer was my first programming language. But I just became passionate about Python and got involved with the community because it was open source. I could start contributing, writing articles, ended up writing some documentation for URL-lib2, which got into the Python documentation because the documentation at that time was pretty poor. So that was my path to sort of discovering Python, discovering the Python community, discovering open source, and starting to become passionate about it. And I was lucky enough to manage to turn that into a career a few years later.
And about how long was it from when you first started using Python until you decided to get involved as a core maintainer?
So as a core maintainer, that happened a little bit after I'd started my career as a professional software engineer. I got this job with Resolver Systems in London, and we were building a spreadsheet application, a Windows desktop application that had programmability built into it right at the very core. So IronPython was initially going to just be embedded as a calculation engine for the spreadsheet, but because the guy who ran the company, Giles Thomas, and the other people in the company were big fans of test-driven development, they discovered that actually IronPython as a dynamic language was way easier to test than the static type languages that they were used to. So they wrote the whole application in Python, and when I joined, I was the first one on the team with any Python experience. And also, they were in my interview. They were the first people I'd actually met programming Python before. My interaction with Python programmers before then had all been online. And after having been with them a couple of years, I went to PyCon in the US, and there I met all of the developers. I'd already done stuff like contributing documentation to the Python project. But we were using IronPython a lot, and And the issue that we had with that was that there were lots of fixes to the standard library that we wanted to go into Python, because there were lots of fixes that we wanted as a company to go into the Python standard library for Iron Python compatibility, but Microsoft at the time hadn't sorted out licensing agreements for their developers who were working on Iron Python to be able to contribute changes to the Python standard library. So I was kind of given commit rights in proxy for, as a representative for Iron Python, even though I was just working with it, wasn't working on it, because I, as an individual, I could make the changes, I could propose them, I could get them committed, and which the Microsoft guys couldn't. So that was how I first became a core contributor. But this was round about the time of the Python 2 to Python 3 transition. So my first real experience of working with the Python core team was in the development sprints after the PyCon, and I worked with Trent Nelson, in particular, the tokenize module. Trent Nelson had made this bet with what the guy who maintained the Python build bots, that he could get them all green on Python 3 during the sprint, which was a ridiculous claim, and he bet a whole beer on it. And then we ended up spending most of the sprint just working on the tokenize module, because in order to maintain API compatibility, and the fact that we were working with files opened as strings that we needed to open for text reading that we needed to treat as bytes, we had great fun with it. So we did get tokenize done, but we didn't get all of the build bots green. And so that was the story of me becoming a core contributor. I was passionate about testing. I'd started writing mock for our needs at Resolver by then, so I was working with the community and the testing in Python mailing list on building a mock object library that would be really useful for Python. And I started to make some much needed changes in unit test, adding test discovery, updating and modernizing a lot of the assert methods and some of the infrastructure around it. So that was my journey into becoming a Python core developer. Again, a lot of serendipity, knowing some of the core developers already and meeting them at the PyCon sprints.
And as you've mentioned in passing a few times, one of the main focuses of your career has ended up being around testing and usability and maintainability of tests. And it's interesting how people can end up sort of focusing on some of these sub-problems within software engineering. So what is it about that aspect of development that you have found so interesting and compelling? And how did you first get exposed to that aspect of building software?
Well, everyone ends up specializing to some extent, but like every part of the world world of software engineering and computers is fractal. As you zoom in on it, you sort of reveal whole new worlds. My favorite example of that is Unicode, where what seems like a fairly straightforward problem of how do we represent internally in computers the various different character sets that are available and communicate those around in an unambiguous ways. But as soon as you get into the sort of the details and the sub aspects of Unicode, right to left combining characters, it's just extraordinary. There's a very basic minimum level that every developer should know, and Joel Spolsky wrote a very good article on that, which is worth digging out. But it's an extraordinary world of its own, and every aspect of software engineering is like that. My particular passion for testing again came out of those very early days in my first job as a professional programmer. I taught myself Python and I taught myself programming to a pretty good standard as a self-taught programmer. I'm pretty proud of how well I'd understood programming, particularly object-oriented programming, which I'd never come across before. But it was really working at Resolver Systems, working as part of a team and building real things and working together on the workflows around that I learned the craft of engineering and how to be a software engineering, how to build big things, how to build things that are stable and robust, and that are easy to change. And I think that ability to change, ability to understand, to maintain, and to change things is vital in order to have a maintainable system. And for me, it was we followed fairly strict test-driven development, and it was really clear to me that, first of all, you couldn't fix and find all of the bugs, but there were a lot of bugs you could fix and find with testing. And what's more, once you've fixed a bug, if you've got a test for it, you can be certain that that bug doesn't come back. And it's always been my experience writing software that, you sometimes end up fixing the same bug several times. And as soon as you write automated tests for those bugs, you can make sure that you don't bring them back. And the same with a comprehensive test suite. You can't guarantee your product works, but you can guarantee that it has a minimum level of quality. There is a threshold of quality that you can verify and assert with testing. And it seemed to me that being able to do that, being able to know that the changes I just made to my software have added the functionality I want them to, and I haven't broken, to the best of my knowledge, existing functionality, that seemed clearly the right way to do software engineering. And also the approach of test-driven development, which, whilst people can get very purist about it, it can become a religious argument. But the approach that I think about testability, which requires me to decompose my problem into parts that I can reason about, think about, that I can test in isolation, that aren't tightly coupled to each other. It forces me to think about design. That approach to design and to designing APIs, you mentioned that I care about usability. My guiding principle, particularly for API design, is that simple things should be simple, but complex things should be possible. So often you get nice and simple APIs wrapping some other functionality that just don't let you do the more complex stuff. And you have to go right down to the low level yourself. Or you see really heavily engineered APIs that expose everything. But the happy parts, the straightforward parts that ought to be a single call with a single parameter is like 4 calls and one of them has 6 parameters. So I think there are nice principles you can take to API design, to product design, from thinking from the perspective of an outside user. And it so happens that in particular the functional, the automated, the end-to-end testing, which is so lacking in many places, but which is so powerful in verifying product quality, that requires you to think about the product from the outside. It requires you to think about the product as a user. And so you start to see usability issues. In order to use this particular software that I'm testing, what's the minimum number of actions I have to perform before I can achieve a simple task? And quite often products will require you to completely buy into the way they model the problem domain and set up sort of 8 or 9 different conceptual things before you can even achieve a simple task. There ought to be a one-button operation. So it's that sort of mindset is a useful way of thinking about product design, about API design, about feature quality, and it's also the way the testing mindset, the functional, the automated testing mindset. So all of these aspects of software engineering that I care about quality, about having processes that work for people as well as machines, all of these things come together in the way we test software. So yeah, that is my passion and has been my focus throughout my career, and in particular writing the mock library was about creating a tool that didn't really exist at the time, enable us to do effective unit testing whilst keeping components isolated and being able to use mock objects. It can also be terribly abused, but so can everything.
Yeah, that's definitely something worth talking a bit more about. But before we get there, as you mentioned, when you first began working with Python, there didn't exist any tools such as mock. And over the intervening years, there has been a lot of development of additional frameworks and techniques available for doing these automated tests, both at the unit level and the integration level and end-to-end testing. And also somewhat recently, there's been a lot of popularity in the area of quick check style tests, such as what Hypothesis provides, where you just automatically generate random inputs to see what's going to break the API that you've built. So what have you seen as being some of the evolution of the language and the surrounding ecosystem in terms of support for testing and how that has developed over the course of your career?
That's been a really interesting journey to watch. At the start of my career, back in 2006, we did full end-to-end functional testing. We did full unit testing, testing excessively and learning to find the balance. We had 3 times as much test code as production code, which for full tester and development isn't that unusual, but we learned all the perils of tests that are very closely tied to the implementation, so then become a nightmare to maintain as you refactor. Been through all of that journey, but back then that was very unusual. And through that period, we've seen a transition of particularly the more enterprise companies moving away from manual testing of products, moving away from no unit testing to where unit testing is basically normal, and where even where there are separate QA teams, most companies have some automated testing. And there are still a lot of companies making that transition. I've helped a couple of companies do that. While I worked for Canonical, we had a manual testing QA team, and I actually wrote a simple testing framework over the top of unit test and Selenium, allowing a QA team to, using very simple scripts, to automate testing. And then more recently, I worked for Red Hat Ansible, and they're in the process well along the way of moving the testing of their Ansible Tower, their enterprise product, enterprise web app, from being manually tested to being automated testing. And this is in 2000 and to using automated testing. And this is in 2018. So the really big change that I've seen is not so much the testing techniques and the testing styles, to a certain extent the tools, but really it's the infrastructure. We now have this fairly well understood idea of a CI/CD pipeline, the continuous integration, continuous deployment. Lots of people tell me that continuous integration isn't suitable for shrink wraps of desktop software on a release cycle rather than web apps. And well, we did continuous integration for a desktop product back in 2006, so I'm not terribly sympathetic to that as an argument on its own. The big problem with waterfall is that it is not that continuous integration and these techniques are not suitable. It's that waterfall is terribly hard to change. Very strongly, waterfall process is very difficult to change. And that, as far as I'm concerned, is the biggest demonstration of why that's such a bad idea. If your development process is very hard to change, then you can't respond quickly to changes. And therefore, a development process that was able to change, that was able to react more quickly, that was able to change priorities more quickly without burning development time, might be a better idea. And that's what's at the heart of Agile. But alongside these developments of standard concepts of how we test and why we test, we have all of the tooling, the equipment for that. We have GitHub and most of the popular GitLab. You can gate check-ins on test runs. That's very easy to integrate with tools like Jenkins. We have Selenium, which is nice, which is very mature. We have a whole crop of new Java script-based functional testing tools like Nightwatch, which are very powerful. So we have this whole ecosystem and infrastructure around normal ways to integrate testing into part of our standard development workflows. And a huge number of developers know how to use that, know how to do that. Pilot test is very widely used. Even unit test with test discovery, it's very easy to build out both the infrastructure and the code to have these test suites. And that's a huge change over the early days when people were reinventing Jenkins for themselves. We kind of did that, built our own distributed test runner system. Code coverage tools now are much more standard, the linters. The whole ecosystem and environment around testing in Python, but in programming in general, has grown vastly since those earlier days.
And given the improvements in the tooling and the visibility of testing and the broader acceptance, what are some of the areas that you see as still being lacking, whether as far as how people approach the testing that they perform or the utilities that are available for building and executing the tests?
So interestingly, at Ansible, one of the things we hit the same problem that everyone does when you do end-to-end testing. It's nice and straightforward to build up Jenkins jobs that build your system, deploy your system, whether it be to the cloud or to your own infrastructure, and then run your tests and then collate and report those tests. That's nice and easy and straightforward to put in place. The difficulty is that where you're manipulating your product or orchestrating your product, your system under test from the outside, the tests start to take quite a long time. And a single testing a relatively advanced feature might take a minute or 2 minutes or 5 minutes. And because ideally, you want test isolation. So in theory, ideally, you want a blank system every time. And you want to build up the state through the actions in the same way the user would. Except that if that takes 5 or 10 minutes per test and you've got 100 tests or a few hundred tests, your test run pretty soon start taking hours. There are various techniques and approaches to solving this, various different trade-off and balances around not over-testing, only testing the specific features you want, not allowing tests to interfere with each other. But one of the simplest ways is just parallelize your tests. If we're running against the web app, if the bottleneck is actually our test runner and the network requests that we're making, then we can just run a bunch of these and combine the results. And it seemed that PyTest has various distributed test runners, but none of them seem to do the fairly straightforward thing we needed to do. So we had to write our own. I think really the some of these best practices, some of the more common answers to these trade-offs and the techniques for solving these problems of how do we do large-scale functional testing of systems and platforms, but not have it take a great deal of time. How do we speed that up, get the results back quickly? I don't think that's a problem. I think there are some better solutions. There are some more common sort of patterns waiting to emerge that can help answer those questions. It's a bit more. It's still a bit of a case of fighting in the trenches with every different situation for answering those kind of questions. That's how I see it at the moment, anyway.
And as you were discussing some of the challenges of these long-running tests and the fact that they have expensive setup routines and then wanting to be able to parallelize, one thing that I was wondering about is the feasibility, and I'm sure this varies with the language runtime that you're using or the framework, but of being able to essentially checkpoint the memory or the state of the data in the system at various branch points within the tests so that you can have common setup routines that would then allow you to spawn off subtests based on the location in the overall flow that you're at so that you can then sort of reduce duplicated effort that's necessary in terms of running the entire test suite.
Yeah, that's good thinking. A common approach to that is to take, so typically in a normal web app, not exclusively, but a lot of the state you want to build up in order to be able to test any particular feature or functionality is really database state. Is what is the system state, and usually system state is modeled in the database, maybe message queues as well. So database fixtures are one way of checkpointing and freezing the system and saying we have a whole bunch of these tests that test the smaller individual features like login, like creating users, like setting permissions, and we don't need to test these every time. So we can checkpoint the database state of a system that's had a whole bunch of standard operations, we can preload these fixtures, and then we can just run tests that test the stuff that we haven't tested, the new and interesting stuff. The trouble then you run into is that your tests then become very coupled to your specific data modeling. You have perhaps SQL dumps are very specific, that are very, very specific to the current model. So whenever you do a migration, whenever you update the model, whenever your system design changes, a whole bunch of tests become invalid. Now, there are ways of applying migrations to this data, but it's something that you have to manage, because the danger is actually that the tests will carry on passing, but they're actually now testing against invalid system states. So there's a whole bunch of trade-offs and things to check there when taking that approach. The other way is to just accept that we have a whole bunch of tests that are dependent on each other, because you can't put a car in the garage without having opened the garage doors first. So we're going to write a test that checks the garage doors open, and then all of our tests that put cars in and out can just rely on that test. So you have one test that fails, implicitly a whole bunch of tests fail, but actually that's the reality. If opening the garage doors fails, then all of those other tests are going to fail. So that's another alternative approach to solving the same difficulty. But that breaks test isolation. Normally you end up with some compromise of various approaches for this. Larger tests that actually test a whole bunch of stuff in one go are, again, another approach. Large tests are bad because they're harder to understand. Ideally, one test should test one thing, but where things this issue seems to be all about finding the least bad way through a bunch of difficult and bad choices.
That sounds like a good description of software engineering in general.
Right. I think that's very true.
And one of the other options for being able to build up system state, or at least approximate it, is through the use of mocks. And there are a number of different sort of philosophies in terms of how mocking can and should be done and the patterns for creating mocks. and how the mocks are used. And so one of the most widely used implementations of that pattern is actually the library that you wrote and was subsequently incorporated into the standard library. So I'm wondering if you can talk a bit about your reason for creating it in the first place and some of the potential pitfalls of using mocks within your tests.
So I guess I'll start with the caveat that one way of looking at mock objects is to say that every time you need to use a mock, see it as a bit of a slight personal failure that this part of the system can't be tested in isolation without a mock object, and minimize the number of mocks you use. And that's a good principle. But the basic theory behind mocks is that you're unit testing to the implementation of behavior. So you want to test the behavior of some particular part of your system under test. You want to be able to, in order to be able to test just that behavior, you want as little of the rest of the system under test to be alive. You want to have to instantiate and put in place as little of the system under test in order to be able to just test the specific functionality and behavior that you're testing. But most components of your code don't work completely in isolation. They're connected to the other bits. That's their reason for existing. So at the boundaries, it's useful to be able to have objects that will have the same behavior as parts of your system under test. So they can be called, they can return data and values, but you can configure them and control their behavior and afterwards interrogate them about how they've been used. And they aren't actually live bits of your system under test. So you can avoid having to make network calls, file system operations, touching the database, all things that you shouldn't be doing inside a unit test that take time and that require big chunks of the rest of the system under test to be active. So having mock objects is very useful. Back in 2006, the standard reference for mocks was a work by Martin Fowler on mock objects. And he defined a mock object itself to be an object that used the record and replay style of mocking. That was his definition of the terminology. And that's where you configure in advance how you expect your mock to be used. You call your code, and your mock either does nothing, in which case it worked, or it blows up because it was used in some way you didn't expect it to. And that was a great idea. It was revolutionary for its time. But actually, it means that every time you use a mock object, you have to specify all the ways it's going to be used up front. So it puts your tests a bit back to front. It puts all your asserts about what will happen ahead of the actions that cause them. And it also means even if you're only interested in one particular piece of behavior, you have to specify all of the behavior. So it makes the test harder to read. And at the time in Resolver Systems, we were creating custom mock objects for each of our tests. So we had a mock cell, we had a mock worksheet, we had a mock grid, and so on. And the advantage of writing them all ourselves was we very tightly specified the exact behavior of these mock objects. They only did exactly what we told them to do. So we knew they couldn't be used in inappropriate ways. But we wrote all of them by hand, and we had hundreds of these things. And I thought Python is such a dynamic language. Through the attribute access protocols, dunder getAttra, dunder setAttra, and friends, and the descriptor protocols, we can completely control the behavior of any object. So we can make one object that is capable of mimicking any object, and it can record for itself how it's being used. So instead of having to configure it all up front about how it's going to be used, afterwards we can have some helpful assert methods on it, check that I've been called with this argument or these arguments, or I've been called twice, and it could be a nice simple object. And the first implementation of mock was like 30 lines of code that replaced, literally thousands of lines of code in the Resolver code base. And then the second problem that we wanted to solve was that Python allows you to, because it's a dynamic language, we can dynamically change and modify attributes and parts of the system under test at runtime. And things like, for example, if we want to be able to mock out the time, we want to be able to control the time that the system sees, so that we can test that some time-related behavior works. It's nice to be able to replace time.time with our own custom function. And in Python, monkey patching is easy. Putting a new object into a system in test, injecting it there is really easy. You can just do it as an attribute access. What's really hard is putting the system back the way it was. Because when you fetch an attribute off an object, you don't know, did it come from the object instance? Did it come from the class? Did it come from one of the multiple classes that it inherits from? Was it fetched dynamically? If the object is a type, it might have come from the inheritance hierarchy or the meta class. It might have been fetched as a property. So if you replace a method by setting an instance attribute, the way you restore the instance method is just delete the attribute you set, and that re-exposes the method. So monkey patching is easy, but unmonkey patching is really hard. So I wrote a patch decorator, and then my colleague Tom Wright worked out, well, look, the context manager API is entirely compatible with the way decorators work. So we can have patch can be a decorator or a context manager, and then you can be really flexible with how you use it. And what patch does is it injects an object into your system for a very specified scope, either during a method call or during the scope of a with block. And then when that scope is executed, whether the test succeeds or passes, it puts the system back how it was. And so this ability to monkey patch the system under a test really straightforwardly, and to have a mock object that could pretend to be any other object and could be configured and also interrogated how it was used, just proved to be a really powerful combination. And gradually it took over the world. There were a whole bunch of other mock libraries, most of them based on the record and replay style. And it just turned out most people used mock, and in the end it became stable and widely enough used that it moved into the standard library itself, which was very gratifying.
Yeah, I can remember when I first came across the concept of mocking and was trying to leverage it in the Python ecosystem, being very stymied by that record and replay paradigm until I came across your work with the sort of canonical or eponymous mock library, and that simplified all of the efforts along those lines. So I definitely appreciate your work on that. And one of the things that is potentially hazardous when you are using mocks is that situation that you described, where you have tests that will silently pass when they shouldn't be because of the fact that maybe the mock is responding to a method call that no longer exists. And I know that one of the ways around that is the introduction of the magicmark object that you created that will actually copy all of the attributes and method signatures from the object that you were trying to substitute for. So what are some of the ways that you can work around some of the potential pitfalls of adding in these mock objects while still being able to easily create tests and prevent some of these erroneous passing cases?
Yeah, you're correct, Tobias. That is one of the greatest dangers with the mock objects, is that when you replace part of your system under test with a mock object that can be called in any way, you can then have, as you say, tests that pass, but your code is actually being used incorrectly, and the mock object is just letting it happen. That's not actually the job of the magicmark. The difference between the mock and the magicmark is that the magicmark supports all of the, or almost all of the Python protocol methods, like done to get item and done to set item, so it can pretend to be a dictionary or a number or anything else that the Python protocols allow you to do. And getting that support, it needed to be a separate type, because there are some checks, like the check for callability, that work by checking for the existence of a done to call method. So you either need a mock that's callable or a mock that's not callable. And the same with the existence of some of the other protocol methods, like done to get item, done to set item. So the magicmark is a separate type. There's a really lovely trick at the heart of magicmark, which I really like, so I'm going to share it with you. Now, normally, so if you create a mock object from a magicmark, you instantiate magicmark, you can set as an instance attribute your mock.dunder get item, and you can set that to either be a function with a signature compatible with the dunder get item, or you can set it to be another mock object. Now, dunder get item and dunder set item, they're only ever actually looked up on the type. That's how Python works. If you subscript an object as if it was a dictionary, dunder get item is looked up on the object class, on the object type. Now, so the first thing that mock does is, when you set one of these magic methods on a mock instance, is it promotes it to the type for you. Now, normally that would mean that all mock objects would now be sharing the same protocol method, because you set the type. And obviously we can't have mock objects interfering with each other like that. So whenever you instantiate a magicmark in the dunder new method, Python has this two-phase object creation. Dunder new creates the instance, and dunder init initializes the freshly created instance. So it's very common to override dunder init, the initialization phase, but the instance has already been created at that point, and that's done in object.dunder new. So in mock.dunder new, every time you instantiate, I think this is for a default mock as well, not just for a magic mock, it creates a new subclass of mock and returns you an instance of that subclass. So now we can attach whatever we want to the type without it interfering with the other types. So with magic mocks, you can set the magic methods, the protocol methods, to be whatever you want, or you can have magic mock create mock objects there for you, which is what it does, without it interfering with any other magic mock instances, and those magic methods live on the type. Now the auto specking is slightly different. What this does is say I have this mock object, but I need it to pretend to be this other part of my API, and there the auto spec function, create auto spec function, which you can also trigger from patch. The patch decorator, just say auto spec equals true, is it will look at the object being replaced, and it will create a mock object that only has the same API, and it will even copy function signatures for you. So then the mocks you create can only be validly called in exactly the same way as your system under test is called. So it prevents those kinds of bugs. It's not on by default, because in order to do this, it has to do some object traversal, which triggers property access and descriptors. And we can't really get around that, because in order to know the API of what an attribute is, we have to fetch that attribute. Fetching the descriptor itself would do no good. We need to know what the descriptor returns. So it's an optional feature, but it does avoid a whole class of bugs.
And in testing, there is also the concept of stubs and fixtures, each of which have slightly different purposes within testing,
Right.
in addition to mocks. So what are your current best practices or heuristics for determining when to use each of those types of substitution method for creating and building your tests?
Well, that's a very interesting question, and actually part of how mock evolved was a bit of a reaction against Martin Fowler's use of all of that terminology of stubs and mocks, and all of that article, which did the testing world a great amount of good, but I do slightly denigratingly perhaps refer to it as the static typing of mocks, because actually mock pretty much does all of them. And so I don't really need to think about which type of mock I'm using. Fixtures are slightly different. Fixtures are a way of sort of putting part of your system in place in test. Fixtures are a way of putting part of your system under test in place, whether that be data or state or what the actual system itself, and a way of sort of passing that to test. And they're very useful. They're very useful concepts. There are add-on libraries for unit tests that do it, and they're a standard feature of PyTest. You can get lost in fixture hell. I've been there as well, so they can be overused. But yeah, they're a very powerful testing concept and very important. You did mention earlier sort of some common anti-patterns with mock, and I think one of the dangers with mock and patch is that so the ideal for code is for the components of your code, their behavior to be tested completely in isolation, totally through the public API, and without needing big parts of the rest of the system under test to be in place. That's the ideal. A lot of people are working on legacy systems with no tests at all, or with very difficult tests, or they're writing tests after the code. So there's a lot of coupling and a lot of difficulty to work around. And the danger with patches, it does allow you to just sort of put in place a huge chunk of your system and then just sort of patch out various bits of it, and then run some of your tests. And you're not really there writing unit tests. You're sort of writing integration tests. And you're very tightly coupled to the implementation. As you change and refactor your implementation, those tests are going to start failing or having weird behavior. And like I said, if you start looking at as every mock that you need to put in place as being a bit of a failing of the code, then you can very easily see where you're having to over mock, where you're really you just want mocking to just be at the boundaries of the component itself. If you're starting to patch deep into other places in the system in order to be able to control behavior, it's a sign that you've got too much of this coupling. And you may not, that may be technical debt that you may not be able to address immediately, but it is a warning sign and an anti-pattern when using mock objects.
And over the course of your career, you've worked in a number of languages outside of the Python ecosystem and built testing capabilities or test suites within some of these various different projects. So, as somebody who has had this experience and this view and dedication to testing over a number of years and a number of languages, what is your perspective on how the state of the art for testing in Python compares to some of the other languages and frameworks and platforms that other people are using?
So my longest stint of working and testing in another language was working with Go. Go was a very interesting language, a much smaller language than Python, a very different type of language, but a lot of similarities. And really that whole experience made me very grateful for how easy Python is to test as a dynamically typed language. Go has a lot going for it, particularly the use of the way you can use interfaces for testability, make it more pleasant than other languages. C# is a nice language. It's hard to test. Go I found to be a language I wasn't that fond of Go. A lot of my contemporaries, a lot of people were very keen on it. It didn't particularly appeal to me. There were some things about it that I really did like. And it's genuinely true that having the compiler, having the compile time warnings, you do pick up a lot of bugs, a lot of typos that you do require your tests to catch in Python. It's a very real trade-off, and the performance advantages of languages like Go and C# are nice and real. It's hard to get around that, but still Python is a lot easier to test. The testing infrastructure is mature. We're still seeing growth. We're still seeing change. We're still seeing development. But it's nice to be solidly back in the Python world and enjoying testing Python again.
And as you mentioned earlier, you came into Python at around the same time as the introduction of Python 3, and as such, you were fairly early in creating a library that spanned the 2 and 3 divide within a single code base. So how has that overall experience changed in the intervening years since you first endeavored in that effort with the mock library?
So as far as I know, the approach for supporting Python 2 and Python 3 compatibility from a single code base in the subset of Python that works with Python 2 and Python 3, along with some other tricks for where you need Python 2 or Python-specific shims. Mock was the first widely used library to release Python 2 and Python 3 support using this approach, as far as I know. And in the early days of the transition, the thought was that we would use tools like 2 to 3, and that people would maintain in a single code base, probably initially in Python 2, and they would use the automated tool to generate the Python 3 version, and they would tweak their Python 2 source so that the generated Python 3 worked. Except you could never, that was really hard to do. So a lot of people just did the conversion once and then maintained separate branches, separate code bases, but that was a lot of work as well. So in Mock, Mock was whatever it was, 1,500 lines of code at the time, plus tests, reaching back into my memory a little bit there. So not a whole lot of code, and I thought it's going to be way easier to do this with a single code base, and there's just a whole bunch of little tricks you can use to get around the incompatibilities. And so I did that, and a lot of those, they're all individually mostly fairly obvious, and other people started doing the same thing. Benjamin Gutworth released the tool 6, which enshrined a lot of those tricks as helper functions. And that was the standard for a long time. It's now much more common for, there are a lot of projects that are Python 3 only. But it's also what I consider now, as demonstrated by Instagram, to be part of what I see as the best way to move a large production system from Python 2 to Python 3. And this is what Instagram did. I think it's a great story. They had a good team doing this, and it relied on them having good tests. They had good end-to-end functional tests of the whole system, and so the production system was running Python 2.7, and so they got the tests running under Python 3 first, and they got the tests in the code base. They worked towards getting all of the tests and the code running both under Python 2 and under Python 3 from a single code base. And the Python 2 tests were passing, obviously, and a bunch of the Python 3 tests were failing. And so they gradually worked. They got all of the tests passing under Python 3. So they're still running the production system in Python 2, but now the tests pass under Python 3 as well. And by the time they got to the point where, we're now confident that the system is stable with Python 3, we can now switch the production code over to running under Python 3, and then we can gradually start to take out all of these compatibility shims and move over to a Python 3 code base only. So you have this awkward intervening period where you're just using the Python 2, Python 3 subset, which is a subset. It is a little bit annoying, but it's fine. It works. There's nothing particular you can't achieve that way. And then you can switch your system over and get rid of all the compatibility hacks. And that worked for Instagram, and I think it's a great story. So those early days where the community was still working out what are the best ways, how do we do Python 2 to 3 migrations, how do we support parallel versions, has morphed into being a great technique for switching over large production systems from Python 2 to Python 3. And it's great that we're now seeing many new projects that are Python 3. Finally it's normal years later.
And as somebody who has been in the software industry for a while now, what are some of the notable evolutions that you've seen in Python and the broader industry?
One of the things that's been loveliest to see has been the genuine push for diversity and radical inclusion within the Python community. That's not to say that there isn't an awful lot of work still to do, but there's an awful lot of people out there doing an awful lot of work in this regard. We have transcode, which is a fixture at most Python conferences these days. We have Django girls and PyLadies, and the incredible work done by all of those people. We've seen the number of women speakers at PyCon and women attendees go up a great deal. We're working on ethnic diversity, other types of diversity as well. And I think that I see that as a competitive advantage for Python, the language. If we can build, and as we are building as much as we're able on humans, a community that is genuinely diverse and compassionate, we will have more developers, we will have more contributors, we will have more people who enjoy and love Python and love the Python community. I think diversity and compassion are these incredible competitive advantages honed by evolution to take an ecosystem from surviving to thriving, and it's lovely to see the whole Python ecosystem more and more thriving in all sorts of niches, as well as in the general programming language world, and with all sorts of diverse aspects to the community. And that's something that I hope continues, because only good things will come out of it.
And most recently in your career, you transitioned to being full-time in offering training and consultation in Python and software development and testing. So where are you currently focusing your energy, and what are some of the grand plans that you have for the future?
So I get to advertise. Yes, I made the transition. I was working with Red Hat Ansible up until April this year. I'm now a full-time freelance software engineer, trainer, consultant, and coach. AgileAbstractions.com is my website. I've been teaching Python since 2011, mostly on behalf of David Beasley, and that's been the most fun thing that I enjoy teaching. Introduction to Python for programmers, so people with programming experience, getting them up to speed with intermediate level Python, 3-day course, and then Python Mastery, which is teaching Python from the inside out and taking people up to expert Python level in a 3 or 4 day course. And I really enjoy doing that. So I'm hoping to do more of that. I'll be teaching effective testing with unit test or PyTest and mock as well, and TDD with Django is another course I offer. Alongside that, the thing I've specialized in recent years is the end-to-end automated testing of systems. Currently, I'm working on a contract with a firm called TestRail, putting in place some automated testing for their test management system, and that's great fun. That's a lovely project. So I'm looking to do consulting or contracting around Python engineering. I enjoy Python software engineering a great deal, coaching teams around development processes and practices, perhaps particularly with regard to testing, and helping companies put in place or extend and expand their automated testing systems is something that I really enjoy doing and hope to be doing more of in the future. So yeah, michael@python.org is my email address if anyone's interested in getting in touch. Mostly working in the UK and Europe, but I can do remote contracts in the US as well. So automated testing of systems or Python teaching, training, that sort of thing. These are the things I love doing and we'll be looking to do more of. I'm hoping to start putting together my own training courses sort of on site here in Northampton. That's hopefully coming up in the not too distant future.
All right. And are there any other aspects of your career with testing or your current work or the mock library or anything along those lines that we should cover in greater depth before we close out the show?
You've let me talk quite a lot, and I enjoy talking about myself a great deal, so I'm very grateful. I think really my main takeaway is Python and the Python community has been so good to me, both personally and in providing a career. Many of my deep and abiding friendships are from within the community. I love the open source ethos and the fact that something that I enjoyed doing, from contributing, from building something with other people, could then provide a career. I think it's a beautiful thing, and that for me came out of a passion for learning and being able to contribute and find a place for that within the Python community. So I'd love to hope that that's still alive within the Python community, and I think it is. I see people coming into the community and finding ways to contribute, and so long may open source reign. Long may open source reign.
All right. Well, you've already mentioned some of the ways that people can get in touch with you, and I'll add those to the show notes. And so with that, I'll move us on into the picks. And this week, I'm going to choose a series of books that I've been enjoying with my kids that are the ology books. So they're things such as Knightology, Dragonology, Monsterology, and they're just this series of books that are very richly illustrated, and they have a lot of little flaps and interesting little tidbits of information and whimsy that are all purported to be these lost tomes that have been rediscovered. So they're a lot of fun to read through, and they're an interesting way to explore some of the different subjects, such as ones that they have on Egypt and mythology. So I definitely recommend checking those out. They're a lot of fun. And with that, I'll pass it to you, Michael. Do you have any picks this week?
So one of my great passions is perfumes, and there are lots of lovely masculine and unisex perfumes, and even some of the feminine perfumes that I adore. And so I'm going to tell you about an American perfume house and two of my favorite perfumes. And the American perfume house is called Imaginary Authors, and they do a beautiful summer perfume called Falling into the Sea. And it's a nice, light, bright citrus perfume, as many summer perfumes open. But then in the dry down, as it gradually, as you get the base notes coming out, as the top notes sort of fade away, it fades down to this sort of 60s suntan lotion smell, and hence the name Falling into the Sea, because gradually over time it changes from this sort of citrus into this sort of reminiscent of sort of beaches and sun in the 60s, which is so that's one of my favorite summer perfumes. They also do another perfume which is very much darker. It lists burnt match as one of its notes, so it's sort of going out in the nighttime perfume for me. It has the great advantage, because it's quite a strong, quite a dark perfume. It's like, if you don't have time to have a proper wash, it sort of goes quite well over that. But it's called City on Fire, and it's this very powerful sort of slightly dark smell, and for me the sort of the imagery of fire is sort of passion. So City on Fire, it's a perfume that I love wearing for going out and enjoying nightlife. So that's there you go. That's one of my passions.
All right. Well, thank you very much for taking the time today to talk about your experience in the Python community and your work in testing and building and maintaining the mock library. So thank you for that, and I hope you enjoy the rest of your day.
Thank you, Tobias. It was great talking to you. Thank you.